I'm Cam Jump. I'm from Winter Park, Colorado, and I'm an Android developer at Fundrise. If you're not familiar with Fundrise, Fundrise is building a better financial system for the individual investor where you can build a portfolio of private assets like real estate, private credit, and venture capital. Okay, so in this talk, I'm going to start going through the background, kind of what charts mean to us and why we need to change them, and also my inspiration for this talk. Then I'm going to walk you through a basic tutorial on how to make a really simple chart using Canvas. Then I'm going to dig more into a case study at Fundrise of designing a charting framework, kind of really go into the architecture there and some of the patterns we use to make the code more usable. Then I'm going to talk about the implementation, and we'll have time for questions at the end. Oh, and also to make my legal team happy, all images and return and projection figures shown are for illustrative purposes only and are not actual Fundrise customer or model returns or projections. Thank you. Okay. So just to get started and to get everybody on the same page, I'm going to just give you these two definitions. The first for Jetpack Compose. If you don't already know, Jetpack Compose is Android's recommended modern toolkit for building native UI. It simplifies and accelerates UI development on Android, quickly bringing your app to life with less code, powerful tools, and intuitive Kotlin APIs. And what is Canvas? Canvas API in Android is a drawing framework which helps us to draw a custom design like line, circle, or even a rectangle. Using these, we can make any shape, whichever we want, according to design. Okay, and so as a finance app, data visualizations through graphs are very important, especially for us. We show returns for our investors, their account values over time, lots of projections, and so having good graphs is very important to us. But our third-party solution we were using was starting to show signs of age. I'm not going to name any names, but the last update was 4 years ago, and it had this imperative API that doesn't always do what you want it to do when you ask it to do. And because it was limited to XML, in order to test changes, we'd have to build our entire app. Also, any complex behavior in this library required a great deal of hacking. On this example on the right, with the scrubber aligning, I just had to do some really dumb math to get that scrubber to line up with the chart, because there's no way to actually link them together. And also had to override methods I should not have been touching to get many different charts to work. Also, the performance was lacking. But as our team requirements were changing, we are starting to have needs for new designs. We had more instances where we wanted to align sliders with chart points, including a line chart, and my previous approach would have been impossible for that. We also wanted to have things like moving label tags and be able to display many of these charts in a list, so we needed to have better performance. Also, many other requirements, including stuff like overlapping gradients. And a little bit more background is my inspiration for this talk. I wouldn't be here today if I hadn't attended DroidCon 2022. This talk by Nicole, Composable Shiba Canvas story, she walks through how easy it is to make, to draw on a canvas. The draggable sheep inspired me to make the scrubber, and she just has a really good example. So if you want a better demo on how to use Canvas, I would go here. But here's our intro to Canvas, and we're going to be building our line chart. So first, to start, we're going to just declare our canvas. What a canvas is it's just a spacer that calls this draw behind method, and draw behind method exposes the draw scope to us in the form of through that lambda. And draw scope is just an interface that lets us interact with the different draw methods on the canvas. To start, we're going to draw our first line. We're going to declare the start and end offsets. So for our start, we're going to get the leftmost, which x is equals 0, and go to the end, which would be the width of the canvas. And for y, we want it in the middle, so we're just going to take the height divided by 2. Next, we're going to draw our y-axis. It's going to be similar, except we're going to put our x's in the middle of the width and go from 0 to the height. So this is where it starts to get a little fun. So we have our coordinate system with 0, 0 being in the top left. And as we go down, our y values are going to increase. And as we go to the right, our x values are going to increase. So, but we're not, our chart axis isn't going to start in that corner unless we're going to make charts just in that second quadrant, or whatever quadrant it is. We're going to start somewhere probably in the middle, depending on what quadrants you want to be graphing in. So now we're going to go into converting values into coordinates. So in order to do that, we're going to need to know the min and max value of our chart. And that can either be automatically given by your data set, or you could declare it. So we're going to calculate x step, which the idea of x step is it's the number of pixels per value from left to right for x step. So for that, we need to know the width, and we're going to divide it by the max minus the min. And similarly for the y-axis, we need to know the min and max and the height. And we're going to calculate it a similar way with the height divided by the max minus the min. So in order to calculate our x-coordinates, we're going to use that x step. But we're going to be doing it a bit differently between x and y because of the right and the down. So for the calculated x-coordinates, we take x minus the min, and we multiply it by that step value we calculated earlier. And for y, since the bottom is actually positive values, we take the max minus the value and multiply it by the step. And from there, we just need to take these points. So these pairs are x values, then y values. And we're going to iterate through those, and then just draw a line from the first value to the next value. And so we already have something that looks kind of like a line chart. Now from there, we can break that into its own method and just draw the lines next to each other. So we've gone from nothing to already having like a line chart that can have multiple lines. And these are just some further examples that I have all the sample code available in the bottom left. But going from that method of calculating points, we can just draw the points however we please and get things such as gradients or cubic lines. Okay, now we're going to go back into more the idea of the third-party library versus building your own solution. So third-party solution, third-party library, it's going to take less work to create something functional. And for better or worse, the code is maintained and tested by outside sources. It's obviously good if it is well maintained and tested, but in our case, it hadn't been updated in about 4 years, so it was no longer being maintained. And that's kind of in the same idea of we had that dependency outside of our organization, and we weren't ready to necessarily start a new relationship with a different dependency. And a lot of times these libraries have a lot more functionality than you need, and sometimes not things you don't need. And I've heard it said it's free as in puppies. It's great, but you still have to keep it alive. Yeah, you have to keep it alive. So in building your own solution, you have more control over what is built, and you can design it specifically to your use cases. And you're going to have that higher upfront cost. And for better or for worse, again, you're responsible for maintaining it, which is good if multiple people in your team understand it. And you learn a lot more, and it's more fun. So we should start simple. The amount of work to use a third-party solution was too high in our case, would have required compromise. And I had kind of shown the team that walkthrough I showed you all at the beginning, that it's really easy to make a simple version of a chart. And if we're just building it for a single feature, then we don't have to worry about too much. We just need to find the differences of that simple chart and build up to a specific feature. And because the new design is it's kind of the screen on the right where we have a sliding scrubber and a moving label bar and this moving highlight tracking bar. This would have been impossible with our third-party solution. And so I got buy-in from the team, or for the org, to at least try to build our own simple version. So I I still wanted to have a charting framework used for multiple charts because I was not happy with the third-party solution. So I started building specifically for this feature, but with the hope and mindset of structuring it to work in other cases. Here I have some common behaviors and edge cases I think you should consider if you're going to build your own charting framework. Since you're building it specific for your use case, you don't have to handle all of these. And there's more edge cases too, I'm sure. But you should at least consider them and figure out what you need specifically for what you're building it for. So kind of in the high level of effort, I have support for line charts, bar charts, and highlighting, which I think highlighting is probably the most complex thing of this. But we can talk about more later. And in medium side, you have labels, drawing and determining which to show. I was never happy with the API of how labels were shown for the third-party library, so I was kind of able to build one the way I like. And then things like displaying, like fills and gradients and quadratic lines. Negative values are things you should consider, since you may not need to handle them in some situations. And we'll talk more about that too. And then just common edge cases like data validation and data bounds you should consider. Also some considerations for, in general, it needs to work for all use cases. It should be easily modifiable for any variations or future use cases. I wanted to build it for reusability, and it should be more performant than our third-party library. Designing with accessibility in mind and testability. And developer experience, I'm kind of considering the sum of all these together and how easy it is for the developer to build with these things. And kind of the approach we're taking is this principle and this pattern. So many of you are familiar with the open-close principle, but software entities, classes, modules, functions should be open for extension but closed for modification. So when I'm building this charting framework, I want it to be really easy to customize towards the different use cases, but I don't want to have to ever touch kind of the base chart and the base chart functionalities, and just a good principle to follow when possible. And the way we're going to be achieving that is through the strategy pattern. Strategy pattern is a behavioral design pattern that allows the behavior of an object to be selected at runtime. It is one of the Gang of Four design patterns, which are widely used in object-oriented programming. The strategy pattern is based on the idea of encapsulating a family of algorithms into separate classes that implement a common interface. The pattern consists of three main components: the context, the strategy, and the concrete strategy. So we're going to kind of cheat a bit on this, but big disadvantage of strategy pattern commonly is how many classes you need and files you need to declare. But I'm more thinking of it as like a mindset when I'm structuring the code. So I'm considering the composable I have as the context. And whenever I'm defining the type of the Lambda parameter, I'm considering that the interface. And then when I'm passing in the Lambda, that's me passing in the concrete strategy. So kind of structuring my composable this way, I'm able to pass in behaviors without modifying it. So it allows me to have increased extensibility. And what that's going to look like from an architecture standpoint is, so here's my base chart. Right now it's just taking in a list of data sets. Now I want it to draw points, but I don't really want base chart to really care about how the points are drawn. So I'm going to declare this draw points Lambda. And this is that behavior that I'm going to be passing in. So now every time we have a behavior that I think might change and that I don't really want the base chart to have to care about, I'm going to declare that type interface strategy and pass that into the composable. So things like drawing points, formatting the labels, drawing the highlight, the min values. I don't really think the base chart should really care about any of these things, so I'm going to pass them in. What I do think the base chart should be responsible for is it's going to be assembling the coordinates, so that kind of that x and y step we talked about at the beginning, it's going to be calculating those for me and calling the lambdas when it needs them. it's going to be responsible for the highlighting, which is detecting the touch, and correlating that with the value in the data set. So both it's going to detect it, it's going to find out which values need to be highlighted, it's going to call the draw method, it's also going to hoist out that highlighted value so that I can update other parts of my UI. So it's going to call these various methods that I'm passed in, and it's going to be responsible for creating the space for the labels and drawing the labels if the format methods that I wrote return non-null. But yeah, this does not really meet our developer experience expectations. I shouldn't be writing 20 or 30, passing in 20 or 30 params every time I need to make a chart. That's why I'm making another layer, which is this line chart, which is going to provide reasonable defaults to my base chart. By providing the defaults, you'll be able to easily have a line chart, but then be able to pass in the different behaviors when you want something different. So the line chart's providing the reasonable defaults in a line chart manner. And kind of you're seeing these interfaces in quotes in the middle, and the composable line chart is implementing them and passing them forward. But because of the responsibilities I declared for the base chart, it doesn't really care how the points are drawn, and everything I have talked about it doing is relevant to the line chart and the bar chart. So because of this, I can pass in the methods of drawing points and drawing the highlight for a bar chart as well. And that way, my base chart can stay the same, but my bar chart can exist with all those behaviors. And if I ever need to make changes in the bar chart, it's not going to affect the line chart because it's all the differences are in a different layer. So that was kind of the design of this, and now I'm going to talk more about how the implementation went at Fundrise. So this feature that we had to build started kind of in the first quarter, and got that built out. Going into the next quarter, we had more line chart use cases in our app, and so made modifications from the single feature line chart to be able to support the different variations, and that went through the design we talked about just now. And then later in that quarter, I made the changes to pass in the behaviors for the bar chart. And at this time, about 80% of our charts are using the new framework, and all of the new charts are. There were some performance issues. The initial performance was pretty good. In the lazy list, we didn't really see any issues, but I was using small data sets. Later, I don't know why, but at the time, our API was giving us over 1,000 points for this line chart on our dashboard, which was more than plenty. And now they give us less. But at the time, I saw that by looking at the layout inspector and realizing that every time I highlighted a value, the entire chart was recomposing. And you can see that behavior there. And so then came the need of like, why am I redrawing everything every time something's highlighted? So I separated a canvas for drawing the points and a canvas for showing the highlights, since the highlight's always on top of the actual points. Kind of how we did this is this, so the way the Compose runtimes work, it decides when to recompose things is through the idea of donut hole skipping. And that's defined as whenever possible, the Compose runtime skips running the donut if it is not reading the value that changed, assuming its input didn't change either. And will only run the donut hole, its scope, assuming that's where the value is being read. And I'm sure that's maybe kind of gibberish, but we'll kind of walk through how we can look at that. So this is this nice little trick that just helps you kind of visualize it. It's not really necessary that I found on Stack Overflow, but it's this idea of wrapping your composable and another composable, and so you can see the actual scope. So in the top, I have my mutable state, and it's kind of outside the scope of both the canvas and the highlight canvas. And this canvas right here, it's not reading the highlighted value at all. But this scope here is reading the highlighted value. So when I make changes and hoist out the value, we can draw the highlight without recomposing the actual chart. Okay, so digging into accessibility and testability for things that I talked about in the design considerations. So accessibility, we're still exploring. A lot of the things I found were more focused on the design side, so not things that I feel like should be directly handled by the charting framework. I know that's a bit of a cop-out, but it is true. The kind of accessibility.gov recommends ensuring the data and variables are clearly labeled, which were handled with our labels. But also we need to make sure there's sufficient contrast between graph colors, and we need to support the visuals with a brief description of the overall trend that's generated by the chart. The best I feel like we can do for the latter one is forcing the developer to provide that trend, but kind of those two things are kind of outside the scope of just showing the chart. They kind of take team-wide initiative to do well. And testability-wise, since we can't espresso test most of this, we're able to espresso test the highlight interactions with our compose test rule, but for any of the UI, we have to cover it with snapshot testing, or we get to cover it with snapshot testing. Here's going back to those kind of behaviors that I think charts should handle, and kind of our resolution. This is a bit of a busy slide. But I showed in the design how we're handling line charts and bar charts. We have that base chart, and we're passing in the different behaviors to get those line and bar charts. Our highlighting, we're handling in a similar way, at least for the drawing, but unfortunately have a data class in there to support specific behaviors. For labels, I set it up so that you pass in a lambda that converts the data value to a nullable string. If it passes a string back, then I'm showing the label, unless they overlap. In that case, we just show the first one that's not overlapping. For the fills and gradients and quadratic lines, passing in draw points, draw methods. For negative values, since we're a finance app, we never really deal with negative x values. Everything's time. So no handling for negative x values, but supporting positive and negative y values. For data validation, such as having empty data sets and sorting points, we're kind of putting the responsibility on the developer. That was just kind of more a design decision. It didn't feel like necessarily needed. And yeah, for data balance, since that can be a product decision on how they want the data to be displayed, it's not necessarily like the min and max. We're specifying that, but having safety defaults. Kind of in summary, didn't get it perfect the first time. As I said, the MVP only built out support for line charts, which was that feature with the scriber bar and the labels. But when we had to add support for bar charts and make it reusable, we had to break the open close principle and make changes to that base chart. Recomposition bugs can be a pain. I kind of showed digging into that recomposition optimization, which fortunately learned a lot from that. But ideally, I wouldn't have had to learn about that. Also, figuring out when remembers should recompose and how those should be keyed was kind of hard too. And then, unfortunately, sometimes have design system changes. So some of the features that I built specifically for the charting framework, a couple months later, our design system decided they never wanted them again. But that's a different problem. Overall, it was a success. We're able to develop litter features with charts much more effectively. Many of these charts we're using in different places with slight variations, and we can easily just pass in different lambdas. We're able to build charts that we couldn't before. Our team, what's going on? Okay, we're back. Our team enjoys it, and building charts is now fun. So our primary takeaways, Jetpack Compose and Canvas empowers us to build our own graphs. Building a basic chart is quite straightforward, as I showed you. Start simple and build specific to your use case, and leverage the strategy pattern for better reusability and extensibility. And so I have some sample code here. It's available on GitHub. All of the Canvas chart sample code is available, and also a stripped down version of what I have at Fundrise is available. It's not really a library. Don't put it in your apps. I don't think you'd want to. But it's there, and you can learn from it, hopefully, and build your own charts. And yeah, now open the floor for questions, and please submit feedback if you have some. Right here.
Hey, how's it going? Thank you for the talk. I just want to ask you, how do you think this approach would work for intensive, like real-time updating of the graph? Like if you have something that requires a lot of animation or a lot of like things that change over time, like a time series, like an analytic time series. What would be the drawbacks, or if you think that this would scale?
Yeah, how often do you want to redraw it? Or you said real time?
Let's say every second.
So kind of in my examples when I talked about the recomposition optimization, without that optimization, when I was dragging like maybe 100 points, it was recomposing at every single point that I crossed, and it showed like no lag out of the box, just using Canvas to draw and redrawing each step as you dragged across.
All right. Thank you.
Welcome.
Hey, thank you for the talk. If you did want to animate individual bars, like for example, when you load the bar graph, you wanted the bars to come in organically and like animate that. What would your strategy be?
Yeah, for this case, I'm exposing that draw method. I don't think it's currently set up in a way that I could like pause. Like it's still on the UI thread. I would probably need to make changes so that I'm able to animate it and like go to a thread that we can wait on and come back and draw. But overall, like being able to pass in the draw method would basically work. Just we need to find a way for it not to happen immediately.
And then so you would just like run that animation method within the draw, like a lambda, and then.
That's what my approach would be, I think, if I had to do that.
Okay.
Okay, well, thank you, everyone.